Welcome to part 6. I'm skipping these problems. That's kind of typical in these keys. I don't really want to tell you what the answer is because this kind of gives everything away. But this type of thinking is going to take a whole page of the test, so please be prepared to answer them. I'm going to skip down to this guy, which I think is really nice. We just want to talk about which ones are correct and which ones aren't. And I'm not going to offer a written explanation, but I'll offer a verbal one, okay? So O over H is 19, be the same thing as 7 over 25. So um, the key here is that you have to kind of imagine yourself at 19, right? And then opposite means you're across. Hypotenuse means across the right angle. So opposite is 7, across the angle is 25. So actually that would actually work out okay. Let's talk about O over A for 71. Now 71, that it's not on this diagram unless you're kind of thinking in terms of the triangle sum theorem. 71 plus 19, that is 90, so this would actually be 71 degrees. So even though it's not explicitly stated like in the diagram, you have to kind of use your noggin a little bit, and that's totally there. So O over A, so standing at 71, you're across and then touching. So that would be 24 over 7, so that's actually a no-go. But it's not a no-go because the angle's not there, it's a no-go because it's the wrong pieces. Number 3, again, sitting at 71, across and then touching. So you're crossing 24, you're touching 7, so that should be, oh, I'm sorry, I misread that. Across from 71 and then hypotenuse. You are across from 24, hypotenuse 25. This is actually a good question. Okay. Let's flip back to 19. They want the A over H, so you want to be a touching and then hypotenuse. Touching 24, hypotenuse 25. That one's good. And then, of course, over A at 19. So you're cross and then touching. You're cross from 7, touching 24. There is not even a 26 in this entire problem, so that is obviously wrong. Okay. Let's go ahead and try to fit this one in as well into this video. This one is tough simply because you have to really kind of think about the diagram here, which is an important part. And so you're actually in this first quarter moon, and so for that to actually happen, the sunlight has to be coming directly in at the sun, or the moon. And then of course you have a distance from the Earth to the moon. So your right angle is actually here. So the tough part about this diagram is kind of realizing the right angle is not the Earth, which seems very natural, but rather it's actually going to occur at the moon because first quarter means the sun's hitting it directly. That's what's causing the right angle. So when I kind of configure my diagram, okay, let's go green. So the Earth here, we have the moon, and then we have the sun. That's what's kind of creating our right triangle. So we have boom, boom, boom. There's our right angle. Let's see what kind of numbers we get here. The distance from the Earth to the moon is 240 million, 240,000, 2.5 miles. We have the angle from the Earth to the sun is approximately 1 degree, which of course makes that 99 degrees, 89 degrees. And they want to know what is the distance from the Earth to the moon. No, sorry, sun to the moon. So I'm going to call that x. So this actually, even though it seems very complicated, is actually not that bad of a problem. It's a very simple setup, and so you have to pick a reference angle and pick two pieces. I was given one, so I'll use that. So let's set it up, reference triangle, actual triangle. If I'm sitting here at 1, I'm across from the 240,000. X is my adjacent. So I'm going to use opposite over adjacent for 1 degree, opposite over adjacent for 1 degree. In my actual triangle, my opposite side is 240,000, 2.5 miles. My adjacent is the x I'm trying to find. Let's rock our trig sheet. Remember to move that, Mr. Collins, when you're done. Opposite over adjacent, third column, 1 degree is 0.0175. Okay. So now as far as solving goes, I'm going to stick this guy over 1, do some cross multiplying. So 0.0175x is equal to 240,000, 2.5 miles. As far as solving goes, let's just divide by 0.0175 to to kill that. 0.0175 here. So going to my calculator off screen, we have 240, 23, nope, 4012, 2.5, and we're going to divide that by 0.0175. Now, we do have this answer here. Okay, shows. Let me check that real quick again. Divided by 0.075. Okay. I'm assuming that's a decimal. It just looks like it's coming out weird. But what I'm getting for the value is 137,144,28.5714. So what I'm getting is about 13 million miles, which seems pretty good. All right. All right. That concludes part 6. I'll pick you guys up in part 7.